Welcome to this video, and we're going to discuss page replacement algorithm using least recently used, or the LRU. So let's begin. First, let us define the least recently used, or the LRU. It is a page replacement, a memory management technique which used to decide which page to evict from memory when a new page needs to be loaded. And here's how it works. Basically, the concept of LRU assumes that pages used recently will be used again soon, and pages that haven't or have not been used for the longest time are least likely to be needed. So, let's begin. Here, these are what we call pages, and it is the table or the space. And let's see and do this activity. So let's begin by the first page, which has a value of 8. So as we can see here, there are still 3 remaining free spaces in this box or in this area. So what we're going to do is just put the 8 on the first space, and of course we encoded the rule of page replacement. Of course, we encoded a new value which is not still encoded in this frame or in the data. So we have to put a page fault, which is symbolized by F. Then next, 5. As you can see here, there's still no 5 encoded. So we're going to put 8 and put the 5 or the second page value on the second space available. Next, 2. Again, just like this first 2 situation, 2 is still not encoded. So we put 8, 5, and 2. But how about 3? What we're going to do here? As you can see, just like 8, 5, and 2, 3 is still not encoded in the graph. But as you can also observe, there is no remaining space available for this value. So this is why we use least recently used, or this is when we use the least recently used method. We go back and see the history here and see which is least recently used. Based on the graph, first you can see that 8 is the least recently value used in the table. So we replace 8 by 3 and copy the remaining values and add a page fault. And let's go back. I forgot something. Of course, we also encoded here a new value and here. So we also have to put a page fault. And I'm very sorry for the error, but keep in mind that whenever we encode a new value in the table, we have to put a page fault. It is the rule. Next, 5. 5 is also encoded already in here. So what we're going to do is just to copy the value of this. Then we proceed to, just like 5, then 2 is already encoded in here, and we can see here in this frame. So just like 5, we copy the value 3, 5, and 2. But as you can see, we did not put a page fault under, because if the rule is when you just copied the value of the existing records or the data in page replacement algorithm of the using list recently used, you don't need to put a page fault. Next, 6. So here it is a new value. So we have to use again the least recently used method. 3, 5, and 2. So we go back and we can see that 3 is the least recently used. So we change 3 to 6 and copy the remaining values. And of course, do not forget to put a page fault. Next, proceed. 1 is a new value. Using again the least recently used method. 652. Here we can encounter these three numbers, and we can see also that 5 is the least recently. So we change 5 into 1 and copy the remaining values and add a page fault. Next, 8 is a new value. So again, least recently used method. We see and go back in here, and we can see that 2 is the least recently. So we change it to 8 and copy the remaining values. Next is 1. 1 is already encoded in here. I forgot again. We have to put a page fault before continuing. We have to put a record of page fault, indicating that you have encoded a new value in the frame. Next, 1. 1 is already in here, so we just copied all the values and you don't need to indicate a page fault. Next, 3 is a new value again. So for the last one, we have to use a least recently used method. 618. 618. So we encountered already the 3 digits that we're looking for, and we can see based on the graph or the records, 6 is the least recently used. So we change 6 into 3 and copy the remaining values. And lastly, since we encoded, as I've said earlier, we encoded the new value, so we have to put a page fault. So again, in summary, we have a total of 3, 6, 9, 10, 11. 11 pages, and which has a 1, 2, 3, 4, 5, 6, 7, 8. 8 page fault. So that's it. I hope this video helps you to understand how this process of page replacement algorithm works. And thank you and good luck.